Um, so for the aerobic training critique that's due tonight, there's a piece at the end, okay, where it asks you to write out and calculate your heart rate reserve and what your target heart rate would be if you were like going to go and do the program. Like if you were going to start that program today or tomorrow, what would your target heart rate need to be to go and do that, like on their very first day? Okay, there's a very reasonable chance, and this would be something that you would want to comment on, that the program that you have chosen is not going to mention using heart rate reserve to calculate intensity, using a percentage of VO2 max to determine their intensity, doing anything other than, okay, this needs to be moderate or heavy or vigorous or light or easy or something, okay? That would be something we would want to comment on, okay? If there is no sort of guidance on all of that, what I want you to do is to make your best guess based upon what they have said, okay? Based upon what they have said. If they've said it's moderate, they want you to go at a moderate intensity, then I want you to try to calculate what you think would be the appropriate sort of percentage of heart rate reserve that would be moderate, okay? If they say that it needs to be intense or higher intensity or something, I want you to try to calculate what you think that would be as well. I realize there's some level of gray area in all of that, but I want to see what you guys come up with. Okay, that's what I want to see. Okay, so I know I'd had a couple of questions about that from people, and so I wanted to try to clarify that here before that is due tonight. That's what I'm trying to get you guys to do at the end, when we get to practice doing target heart rates and calculating heart rate reserve, right? But then also you get to practice using that and applying it to an actual exercise program. Okay. All right, Nia, your question.
Okay, so two questions. One on what you just said. So to calculate the target, like the target heart rate, we have to use like VO2 max and like the other stuff, right?
So you need your resting heart rate.
Mm-hmm.
You need your age predicted max heart rate. And then you can use those two things to calculate your heart rate reserve. And then you need to take whatever percentage of that heart rate reserve that you feel is appropriate. So the percentage of heart rate reserve at which you want to exercise is going to almost exactly correspond to that percentage of your VO2 max. So if you need to exercise at 60% of your VO2 max, then you would like to exercise at 60% of your heart rate reserve.
Okay.
So you would find your heart rate reserve, find 60% of it, and then add that back into your resting heart rate. And that's your target heart rate to be at 60% of heart rate reserve, which will correspond roughly to 60% of VO2 max.
Okay, so if our program like says like a brisk walk or like a jog, how would we calculate like a percentage just from that?
Okay. Anybody want to weigh in? I felt like there was some guidance given on that in a couple of the slides. Am I misremembering what I've actually shown you guys? Can somebody look back and let us know what they think? Gavin, can you help us out? You have any guesses about what percentage of VO2 max do you think I should be at if I'm doing like a brisk walk or kind of a nice, easy jog?
I'm looking at the slides right now.
Okay, he's looking furiously back through. So, Nia, do you remember, Nia? So, like what is that moderate intensity activity? Is that vigorous intensity activity? Like, what would be our descriptor of kind of a brisk jog, or I'm sorry, a brisk walk or a light jog, Nia?
I would say like moderate, and if you're jogging maybe a few miles, then vigorous.
Okay. Okay. So, Gavin, have you found anything? No? Okay. Then I should probably, we will clarify that. So moderate intensity physical activity is usually going to be somewhere in the like 30 or 35% of VO2 max, up to maybe, depending upon how fit you are, up to maybe 50 to 60% of VO2 max. That's going to vary. That top end is going to vary a little bit based upon how fit you are and some of those things. Okay. And then probably anything that is over somewhere between 50 to 60% is going to be considered vigorous. Um, and so that's kind of those, that's what I would say is going to be the range. So like a light jog in you guys might equate to 45 to 55% of VO2 max would be my guess. But like in an older person who's not particularly fit, that might actually be like 70%. So it's going to vary, but that would be my guess. It's kind of right in those ranges. Okay.
I think it's on like the 5th or 6th slide.
On the 5th or 6th slide, Savannah. Okay. I'm trying to pull up the thing. No. So the best guidance that I can think of here, and I'll just share my screen, is probably on, I think it's slide 20. On my thing, it's slide 21, and I hope I pulled up the right one. But it looks like this. Right. So what we're going to think of is kind of health benefits. This is going to be the health side of things, like this 40 to about 60% of heart rate reserve is going to be like 40 to 60% of VO2 max. This is moderate to kind of very, very low end vigorous intensity activities. This is the stuff that's probably going to basically help us meet those kind of minimum 150 minutes per week guidelines. And then that's going to give us health benefits. And then to really begin to increase VO2 max, we probably need to be in that vigorous intensity range, or kind of somewhat kind of middle vigorous to kind of higher end of vigorous, which is the 60 to 80%. And then really vigorous is basically everything. It's going to get us all the way up to 100%. But that's probably what I was thinking of. This is probably kind of the best indicator of those things. Yeah. Okay. Is that helpful?
Yes. So for people like our age, it would be like for moderate,
You
it
can
would
pick
be
like 50% would be fine. That's great.
and then anything higher would be vigorous.
Yeah, it's probably safe if you really want to do a cutoff for vigorous to just call it 60% and above is probably vigorous in a college age population.
Okay. Also for the lab too, are you going to email us the data for us to make the graphs and things?
I will email you the data when you guys email me the data. So yes, once I have the data from the rest of class, I will be more than happy to share it with the class. But I need it from everybody first. So I have gotten maybe 7 or 8 people have sent me things. If I was to look and try to count, and then several of you that sent me things you sent me stuff, but you didn't actually send me your estimated VO2 max value. You sent me how far you walked, you sent me your heart rate, you sent me your age, you sent me your weight and things, but you didn't actually send me your VO2. And so please look at what you sent and try to make sure that you're getting me the right information. Okay. I also had a couple of questions on doing the calculation. In the equation, it's going to say like 6, it's like 6 MWT or whatever value. You just need to, in that, when it says that, you just put in the distance you walked in meters, and that's it. Okay. You don't have to multiply anything by 6. If you do that, you're going to get a VO2 value that's going to be like 170 or something, which hopefully you guys would think maybe I'm not quite that fit. If I am that fit, I should be like at the Olympics in a few weeks and things like that. Okay. So just keep that in mind when you're looking at those things. All right. But that's what I need. So everybody, please, by the end of today, if only because it will make your classmates happier with you and give you more time to mess with the data to finish the lab, I need that today. Okay. So go out, do your 6-minute walk, do that calculation, send me the stuff, and I'll try to get that out hopefully by this evening to everybody. Okay. Otherwise, we're going to sick Nia on everybody. Okay. Other questions and things we need to mess with before we kind of launch back into talking about body composition and obesity, and then we probably can get into a little bit on the back end today of some health appraisal stuff. Anybody else have things or problems? No? Okay. All right. So everybody at least like flash your cameras at me, like wave at me, say hi, Dr. Black, what's happening? Just want us to get a little, we'll do a little thing. There we go. There's Madison. Right, there we go. Oh, Erin's got her cat. What's up? Addie's got her dog. These are good things. Okay. Perfect. Perfect. So we'll do a little group work later on on the back end of class today when we get to the health appraisal thing. We'll do another little group activity. But until then, I'll try to ask some questions as we go along and keep you guys on your toes in the midst of all of this. So, okay, let me get the correct PowerPoint pulled up. There we go. And then I'll need, you guys remember where we stopped? I feel like we had gotten to somewhere. Do we stop here? Do you guys remember? Was this about where we stopped? We talked about MRI and DEXA. Is that right?
Yeah.
Okay. All right. So MRI, DEXA, these are kind of these high resolution imaging techniques that we can do to quantify what you're made up of. MRI is obviously the best and the least feasible thing you could ever think of doing for all of this. DEXA is good. DEXA is very good, a little bit more feasible. And we can do those things in our department. So generally, if we want to know somebody's body composition in our research studies, we will do a DEXA scan on them. Okay. So there are some other measures though, right? If you care about what it is, and if you are trained, especially with skin folds, then they can be relatively accurate, okay? But what's gonna happen, and when we do lab number 3, when we do the obesity lab, so towards the end of this week, what I'm going to do is you guys are gonna send me your height and your weight and your age and your BMI, and I have data from classes from years and years of doing this, and I'm going to try to match you up with someone, and we'll send you some skin folds, and you can see a little bit about how we would do the skin folds if we were able to. Okay, but a skin fold assessment is done where we basically pinch and measure the distance or the thickness of subcutaneous fat at various locations on your body. Okay, and the idea behind doing skin folds is that a majority of the fat in your body is going to be right under your skin. That's where we're going to store it, okay? As I like to joke around, it's my sort of flabby, it's kind of your flabby tricep, okay? So if possible, everybody do this for me, okay? Everybody do this. Everybody turn your cameras on, okay? Turn your cameras on. Put your arm out like this, okay? If you're wearing sleeves, it's okay. You can still do this. But I want you to take your thumb and your middle finger from one hand, doesn't really matter, and I want you to squeeze on your tricep like so, okay? Squeeze in your tricep, and I want you to push, basically, and pull down at the same time. And what should happen is you should feel, basically, the muscle roll up, okay? And what you're left with down here, okay, mine can wave at you. We do all of this. What we're left with is what we would call a skin fold, okay? So when we do the skin fold measurements, we would do something like this, where you pinch and you pull out, and you're trying to then get a place where you've got these parallel, okay, parallel sort of sides of your skin with the subcutaneous fat underneath. Okay, were you guys able to kind of feel what that was like as you do all of those things? Of the ones that we do, the tricep is generally a pretty easy one from a demonstration standpoint, and we'll talk through in a few slides what the actual, like, all 7 sites where we measure them are, and I'll give you guys a little bit of an idea of which ones are kind of easier and which ones are a little bit more difficult to do. But that's the general idea, okay, is we're going to pinch that way. We then grab on with these things that you can see on the screen here with the skin fold calipers, and we get a measurement. Okay, and that measurement is usually in millimeters, and so the more subcutaneous fat you have at a given location, the larger that skin fold is going to be. The larger the fold is, the thicker the fold. And we take all of these, we add them together, we plug them into a fairly complicated equation that we're going to see, something that's called the Jackson-Pollock equation. And based upon your skin fold thickness, your age, and whether you're a man or a woman, then it will spit out, weirdly enough, not a percent body fat, but it spits out a body density. Okay, because remember, this is still a measurement that is based upon densitometry. So we use skin folds to calculate a density, and then we take that density and we plug the density into a different equation that I will also show you guys, something called the Seery equation, which is we're going to also use for bioelectrical impedance and underwater weighing, and for the air displacement plethosmography. But we use the skin folds to get density, and then we use density to get percent body fat, okay? If you are good at marking and making the measurements doing skin folds, they can be pretty accurate, you know, within 4 or 5% one way or the other on those kinds of things, okay? People that are well trained at doing this, this is a pretty reasonably good way of doing things, okay? One of the things that we had class in person, we do skin folds, okay? You have to measure skin folds on some other people in class. You guys, if you've never done it before, are going to be terrible at it. You're not going to be very good, which leads to either dramatically under or overestimating the skin fold thickness. Most people tend to underestimate because you don't really want to, like, grab and pinch the stomach fat of your partner, or grab and pinch their side or something, which makes total sense to me, right? And so we don't really kind of get in there and do it as vigorously as we need to get the most accurate measurement, and we tend to underestimate. Okay, but that's one way that we can do things. Another way of doing it is something that a lot of you guys have probably done. If you go over to the Huff, kind of outside the turnstiles, they have a machine that looks like this. Lots of gyms have them. I assume some doctors' offices have them, but it's a thing that's called bioelectrical impedance. And so what it does is it predicts your body composition from the resistance of your body to the flow of an electrical current through it, okay? Muscle is mostly water. Some of your other tissues, mostly water. Water is a very good conductor of electricity. Fat, on the other hand, is an insulator. Fat does not conduct electricity. So if you have more fat, then your body is more resistant to the flow of an electrical current through there. And so what happens is we see our woman standing on this thing. You will note the metal plates down here under her feet. What happens is that there's a very weak, completely imperceptible electrical current that is applied through one foot. It goes in on one foot and it travels up into her body, and then we measure it trying to come out on the other side. Now there are other ones where you can hold on with your hands. You hold them out like so. We can do it this particular way, and it runs from one hand at the arm and it tries to come out the other side. The theory is still the same, okay? It is to calculate this based upon the resistance to current flow. This thing is amazingly, amazingly inaccurate, okay? It's very sensitive to how much water you have in your body, so how well hydrated you are. It's amazingly sensitive to, it makes these wild assumptions based upon age and body type. Usually you put in your body type, and as well as sex. And so if you are kind of an average, middle of the road, not super lean, also not morbidly obese, just kind of average person, it's probably plus or minus 5 or 6% on those people. In people that are very, very lean, okay, that have very low body fat, relatively high levels of muscle mass, it tends to underestimate, and in people that are kind of morbidly obese, it tends to overestimate. And so it's again, it's a measure of things, but there's a lot of error that's going to be in there, because it looks like it should be scientifically sophisticated, but in fact it's actually not particularly sophisticated. Okay, so don't get sucked in by some of those things. Another thing that we do is something called underwater weighing, and for the longest time this was the gold standard, but it is no longer considered to be the gold standard for our indirect measures. Okay. Again, if you take exercise physiology lab class, you guys will do this underwater weighing technique and compare it to some other ones. But the general idea is we basically put you and we dunk you underwater. You sit on a little swing underwater, and we see how much you weigh underwater. Okay, just what it says. And so people whose body is more dense, because we can measure the amount of water that you displace, we can also measure how much you weigh underwater. People that weigh more underwater have less percentage body fat than people that weigh less. And so here we have Jack and we have Dave, and Jack and Dave are both 6'2" and weigh 205 pounds. And Jack is very clearly a swimmer of some type, as you can tell by his very broad shoulders and narrow waist. And then Dave is, I'm not really sure what Dave is. Dave is sort of rocking his dad bod in some ways here. Here we have, I sort of jokingly say we have college Dr. Black and we have Dr. Black now here in the midst of these kinds of things. But they are identical, but underwater, Jack weighs about 1.5 kilograms more than Dave does. And so that is going to give us, for their sort of displacement of things, if they displace basically the same amount of water, he weighs more, so he is more dense, therefore he has more muscle and probably higher bone mineral density. And Dave is going to have less muscle relative to his size and have a higher percentage of subcutaneous body fat. Okay, and so we can do this and get a relatively maybe within 3 or 4% kind of accuracy estimate of what your body fat is going to be. So we calculate your density, we plug that density into what I said which is called the Seery equation, which I'll show you guys in a few slides, and it spits out a percent body fat to us. Okay, so we have a tank, or it's really like a giant, really, really deep bathtub that we do this in. It's in Dr. Larson's lab. When I was a grad student at the University of Georgia, the tank was actually above ground. It was made out of plexiglass, and so you could see into it. It's a really kind of strange sensation if you don't like being underwater. You kind of have to hold your breath for about 30 seconds and go under, but you have to blow all the air out of your lungs to start with before you begin to hold your breath. So it's kind of a psychologically strange type of thing to be able to do. And so it has, with the advent of people having more and more DEXA scanners, it has mostly kind of fallen out of favor, that people just throw you on the DEXA thing and we can get a more accurate estimate of body composition. But a perfectly reasonable way of doing things that you guys may encounter at some point. Okay. Moving along, somebody asked about this the other day. And we have one of these downstairs. You guys can use this in your capstone project if you want. But another way of doing things to calculate body density is something called air displacement plethosmography. And it is done in something that is commonly called a bod pod. What you see in the picture here is a bod pod. I don't know whether it's going to evoke some sort of alien horror story kind of vibe to you or something here. But what happens is you sit in this chamber and the chamber blows air across you, okay? And we're going to calculate body density from body mass and body volume. And we figure out your body volume by the differences in air pressure from one side of you to the other side of you. And so if it applies a known amount of air pressure on one side of the chamber, and then it measures sort of the change in pressure as that air goes over your body on the other side, then Boyle's law tells us that sort of the ratio of pressure on either side is inversely related to the volume on sort of either side. And so if we know the volume of the chamber and we know both pressures, then we can relatively easily calculate the volume that you are occupying inside that chamber, okay? So it's this idea that gas volume and pressure tend to be inversely related. And so the more volume you occupy, then the higher the pressure is going to be basically on the other side of you in that particular way. So there's some issues with the bod pod. Ideally, you need to have ideally, you would get in basically and you would shave all the hair off of your body and you would get in the chamber completely naked, and we would do it that way. No one is allowed to do that. You want to use ours basically. We would have you put on sort of like very tight kind of form-fitting like clothes, kind of like a spandex bodysuit or a very tight-fitting like workout shirt. And what I sort of growing up we would call bike shorts. I don't really know what you guys refer to them as now, but kind of tight-fitting workout shorts that people seem to now be wearing, both men and women, just like out and about, which good for everyone. And then you would put like a shower cap on over your head, and then if possible, we would want you to sort of, if you have a beard, you would have to shave your beard to get a good accurate measurement. And ideally you would shave the hair off your arms and those kinds of things, because what happens is when the air flows by, if it catches clothing or any kind of hair, then that creates turbulence and it depressurizes the air, and it can give us these very, very inaccurate measurements. Okay, so there's a little bit of nuance in all of that that are going to make it a little bit trickier for us to be able to use, or at least make it kind of arduous on participants wanting to use it. So again, something that looks really sophisticated, but is actually not that sophisticated. Some gyms and places have these things. So there we go. So that's kind of how the bod pod works. And again, it's about as accurate as the underwater weighing, usually within kind of plus or minus 3 or 4%. So it's a very reasonably accurate kind of thing. Okay. We talked about DEXA. We talked about what you get from the DEXA scan. We talked about MRI the other day. These are what MRI things look like. Okay, so let me talk a little bit about the different skin fold sites and how we're going to measure skin folds. Okay, so when we do the fold, we would ideally like for it to look like this. Okay, now, but I want you guys to think about when you pulled on your tricep. Okay, at the tricep, it's pretty easy, right? Because a lot of us tend to have a little bit of kind of extra skin and things around our tricep. It's pretty easy for us to get this nice kind of pulled out fold where the sides are going to be relatively parallel to each other. But at some of our other sites, this can be much more difficult for us to achieve, especially in people that have a fair amount of subcutaneous fat. And I'll talk a little bit about which of those sites those might be. And if you want, while you're just kind of sitting there, you don't have to show this to all of us on camera. You can try to pinch yourself in these locations and see kind of what you think with this. Okay. So when we do this, there's two possible ways to get this. Okay. There's not two ways to measure, but there's two sets of kind of collections of sites that we can use. So we say we're either going to do a 3-site skin fold test or a 7-site skin fold test. So it is just what you think. In the 3-site test, we will pinch in 3 places. Those 3 places will differ between men and women based upon that men and women tend to store subcutaneous adipose tissue generally in different places between the sexes, or we're going to do 7 sites. And the 7 sites are all going to be the same. Okay, so they're the same for men and for women. And so the 3 sites is just a subset of the 7. So when you do this in lab, I will give you things for the 7 sites, and then you will calculate your estimated percent body fat from both using the 3 sites that would correspond to your sex and then all 7, and then make some sort of predictions and assumptions between those. Okay. Okay. So we'll do the 7 first, and I'll walk you through sort of what is where with all of these things. Okay. So on your chest, the chest side is going to differ ever so slightly between men and women. But in the chest, we're going to measure, if you guys can see me in my picture, we're going to measure basically from kind of right here at the top portion where your shoulder meets your armpit. And you go, in men, you go down halfway between the crook of your armpit and your nipple. So it's about halfway, and we pinch. It's this diagonal sort of 45-degree angle fold that comes out like this. Okay. On women, we only go a third of the way down. We don't go halfway. It's only a third. So the women, it's going to be a little bit closer up towards the armpit. Okay. That's the chest. We've already done the triceps. Okay. The abdominal site is the same between men and women. The abdominal site, you find your belly button. Okay. And then we're going to go 2 centimeters to the right of your belly button. And we're going to make what's called a vertical fold. So you're going to try to hold your fingers like this and pinch, sort of coming in from the left and the right, to make a fold that runs up and down, right down there, over your abdomen, kind of over your lower abdominal muscles. Okay. Now, as someone that has become a statistic, as you guys will see a little bit later on, I have a little extra tummy fat down there. So when I try to do that, one, it hurts to try to grab and pull away from there, but it's pretty difficult for me to get. It doesn't want to pull away from your abdominal muscles in the way that sort of the extra skin around your tricep tends to. It's a little bit more difficult there to get a nice kind of pull it out and away and get nice parallel sides on the fold if you have a person that tends to have a little bit higher level of adipose tissue there. Okay, so just kind of have to keep that in mind. Subscapula is one that is taken kind of below the inferior angle on your scapula. You would put an arm back behind your back. Okay, I don't know if I can do this. I don't even know if you guys can see me from behind, like so. But you put your arm and you kind of turn around like this. Okay, and then we go down here on kind of below the inferior angle of your scapula, and we pinch from down there. Okay. The suprailiac site is right over the top of your iliac crest. Okay. This one tends to run slightly at an angle. And so if you locate your iliac crest and then sort of run along the top of your iliac crest at approximately a 45-degree angle, that's going to kind of match up with your inguinal fold, which is that area when you sit down where your thigh kind of comes up. So it sort of angles down at that kind of 45-degree angle there. That's where we're going to measure the suprailiac. Okay. Mid-axillary is just over your ribs, sort of right here. Okay. And then your thigh is at the midpoint between the top of your patella and the head of the femur. So it's kind of right at that halfway point. That's going to be in your thigh. Okay. Of these, to me, the suprailiac is the one that's the most difficult to actually locate on most people, because you have to really. I always have a hard time. Like, you have to feel around in there and locate the head of the iliac crest, and then try to follow the kind of the angle of that one. And then the thigh most often is the one that's the most painful to get on. It's the most painful to get on most people, because we tend to have a lot of kind of skin tissue, and this one tends to be one of the places where almost everybody has the largest amount of subcutaneous adipose tissue. Is kind of around their thigh there. And so it doesn't always want to pull up particularly easily. And so if you have to grab a significant amount of tissue, at least it's been our experience that that one also tends to be the one that's kind of uncomfortable. Okay. So you would measure at all 7 of these sites. You would add up your numbers and plug them into some equations that you guys will see. And then that will give us a body density, and then we use that density to calculate our percent body fat. Okay. For the 3 site, we use chest, abdominal, and thigh in men. And then in the women, we use triceps, suprailiac, and thigh. So we're basically changing sort of the 2 upper body ones between men and women. And a lot of that is based upon that there are just going to be some differences in where men and women tend, in a very general sense, to carry the largest amount of subcutaneous adipose tissue. Okay? Men tend to have their sort of stomach adipose tissue be a little more kind of central, a little more visceral, which is why the abdominal one is used. Women tend to be a little more kind of out towards their hips, which is actually good from a type 2 diabetes standpoint. So we use the suprailiac, and then women we use tricep, and men we're going to use chest in that particular way. Okay. Anybody have questions about that? Nope. Okay. All right. We talked about biological impedance. Okay. So what we're going to spend kind of the rest of the slideshow talking about is not so much how do we quantify these things, or what are the techniques, but what we're going to talk about is the idea of obesity and overweight and why potentially it's not so great for us. Okay, so when body weight exceeds the normal or standard weight, and again, right, like what is normal, what is standard, we can have a debate all day long about those 2 particular things. Okay, but when you have more weight for your height and kind of body frame than what we think you need, then you're either going to be considered overweight or obese. Okay, in general. And so one of my master's students, for her master's thesis project this year, there are some databases from studies that are done every year that are available from the Centers for Disease Control. And we did a thing looking at kind of overweight and obesity and physical activity and predictors of how people were answering questions related to their experience of sort of normal movements being painful. And what you find is that for the most part, some of them had DEXA scans, is that if you look at the body composition between the people that are kind of classified by BMI as being overweight or obese, that in general, they weigh more, but all of their extra weight is mostly going to be adipose tissue. Okay, so you have an excessive amount of body fat. And most of the time, we're defining overweight and obese simply using body mass index, which remember is not actually a measure of body composition. It's a terrible measure except for all of the other measures, which are actually in some ways worse. Okay, so here we have our guy who is what we would call quote unquote sort of normal weight. Here we're gotten a little bit, although to be honest, our picture here, this guy in the middle would probably be very close to having a BMI of 30. If I was to guess. And then here we've got somebody that's probably got a BMI of like 35 to 40 or something like that. And you can just look at these things. And in general, while these 2 sort of the kind of versions here on the right are going to have more muscle mass, the primary thing that they have that is more than kind of our quote unquote normal weight fella is going to be additional body fat. Okay. So, and I'm showing you these data, and I really should download the most up-to-date version, but it's the number that I'm going to show you up here is correct, but they have more up-to-date graphs. But this, I think, illustrates just kind of the point that I want to make. About 70% of adults in the U.S. And so in these numbers, in this particular instance, they're considering an adult, I believe, to be anybody that's 20 years of age or older. Why they chose 20, there's some debate about all of that. But about 70% of adults in the U.S. have a BMI of 25 or older. Okay. If we throw out college age individuals, if we bump it to 25 or we bump it to 30, then the percentage goes up even farther. Okay. it's going to go up even farther. And so what you can look at is, here's data on all of this showing we've got men in blue and women in white. And it's just showing the kind of percentage of the population, of the adult population, that we're classifying as all of that. And it's just got some trends from the early 60s, basically the early 70s, kind of the mid to late 70s, the late 80s, and kind of up to about 2000. What I can tell you is that this trend has sort of continued to gradually go up to present day, but this has been going up, right? We have a larger percentage of adults in the US that are considered overweight now than we did 10 years ago, and it basically goes up sort of every 10 years. At some point, obviously, we will, I would imagine, kind of reach some sort of critical ceiling effect, kind of top end portion of all of this, I hope. Depending upon what years you try to slice the data through, you can make an argument that in the last like 5 to 10 years that we've begun to level this off a little bit, but we're still at 70% or something, which is not good for us. So just remember, being overweight by BMI increases your risk of mortality from anything. It increases your risk of having cardiovascular disease and things of that nature, okay? So this is a predictor of poor health consequences, okay? So, and these numbers have gone up. They're almost 40% now, but about somewhere between 30 and 40%, or a third, and about 40% of the adult population in the US is obese by BMI. So you have a BMI over 30. These people are a subpopulation of the data from the previous slide. So the previous slide was people that are overweight and people that are obese. This is just the people that are obese. And what you can see with all of this is that really where this began to see kind of a marked increase was in the mid to late 80s. Okay, we were doing kind of, I don't know if good is the right word, but it was at a relatively kind of stable place by BMI, and then it's begun to go up. I find some of these data to be really fascinating. If you look at the overweight data, we have a lot more men that are in sort of between 25 and 30. They're a higher percentage than women, but then we have women, obesity in women that are over 30, that there tend to be a little slightly larger amount of women that are sort of over 30 than there are men, which is a thing we don't really have a good explanation for on all of that, okay? But again, these numbers have also increased, and that being obese by BMI, so BMI over 30, leads to not just a little bit of an increase in risk of all-cause mortality or cardiovascular disease. This leads to a very significant increase in risk, okay? A very significant increase in risk. So to further parse some of these data down, we can look in children, okay? And again, the trends are going to be roughly the same. I haven't pulled the data. I need to just go to the CDC's webpage and get new data. These were from a textbook that we had that we just kind of pulled together pretty quickly. But down here, kind of in blue and white, we have boys and girls that are kind of adolescents, so 6 to 11, pre-puberty. And then in the red and the green, we would have what we would generally consider to be maybe not young adults, but for the most part, probably kind of right around the onset of puberty as we're working our way up towards adulthood. As you can see, we're at this cut point at 19. We consider the adults to be 20 in some of these samples. And it's kind of the same sort of thing that we saw with the obesity rates, that pretty stable kind of values until we get here into the late 80s and the early 90s. And we've seen some kind of steady increases since then, okay? When we get into talking about type 2 diabetes, it used to be unheard of for us to see the development of type 2 diabetes in like teenagers and those things. And now it has become more and more and more common. And a lot of that is related to this increase in obesity rates that we're seeing at these age levels. There's a host of reasons for all of this, and it's complicated. Some of this is food, some of it is lifestyle. Some of this is, right, like lifestyle, like not exercising. They're taking PE and recess out of elementary schools. Kids don't ride their bikes around the neighborhoods anymore. They don't go outside and, play kickball or soccer or whatever else in their neighborhoods. They're at home on their phones or playing video games or various things of that nature, which there's some good and some bad to kind of all of those things. But this is kind of what we've got to deal with, and kind of what the reality of our situation is. Okay. So here are the same data, and these are from 2 years or 3 years ago now, from 2018. But it's the prevalence of self-reported obesity. So this is the prevalence, the number of people that have a BMI of 30 or greater, and it's broken down by state. Okay. So the dark red states have a higher, they're over 35%. The kind of weird, kind of orangey mango color is 30 to 35. Green is the lowest. Yellow is kind of, excuse me, going to be the next. And what you can see is that if we look here, right, sort of through Appalachia and kind of parts of the Southeast here into this kind of weird, whatever we would want to call this. I'm trying to remember from when I had like geography and stuff when I was in like 7th grade, we talked about that, like Louisiana was the boot and Minnesota was the, like had a hat on. Remember what we called this kind of straight kind of north-south region here. But you can see this, and people tend to be a little bit better, a little lower rates of obesity kind of out in the west, okay? And then here in the northeast, and then the best ones always tend to be in Colorado and for the most part in Hawaii. There's a lot. Gosh, it's so beyond the scope of this class, but there's a lot of reasons behind all of this, though. I think I told you guys we have friends that live in Seattle, and it was 104 degrees in Seattle yesterday, which I think was a record high for forever on that particular date. Like our friends in their previous, their house they're in now does have central heat and air, but their previous place they didn't have air conditioning. Can you imagine it being 104 degrees? It's going to be like warmer today. And I think there's like these kind of record heat waves here. Like it was super duper hot in Portland yesterday and some things. And so partly we used to think that people were less obese out here because the weather was more temperate and people could get outside and be more active and do some things. And we may be seeing some changes based upon all of that. And that was one of the reasons why people are more obese down here in the Southeast, because it's hot and you don't want to go outside and you're not going to be quite as active in some ways, in combination with cultural things and food and socioeconomic status and education and a whole kind of host of other things. Okay. So there are, and I want to point this out because I think it's really, really important. There are some what we would call sort of ethnic differences in the prevalence of obesity. And those ethnic differences are also going to play a very, very key role in ethnic differences in the prevalence of, say, cardiovascular disease and type 2 diabetes. There are certain races or ethnicities, and I apologize, I should have looked up and gotten my terms a little more sort of kind of correct on all of that. But what you have and you see here is this is the prevalence of self-reported obesity among what we're going to call non-Hispanic white adults, so Caucasians in essence, people that are generally going to be of European kind of heritage and descent, right? So if we look back at, here's everybody all together, here's white people, okay, in a very kind of way to put that. And what you will note is that there are fewer places where we have dark red, and then California slides into the green in some ways, and the folks in Hawaii are going to have an even lower kind of percentage, as well as DC. So in general, non-Hispanic whites tend to have a lower prevalence of obesity than folks of Hispanic descent, folks of sort of African or African American descent, depending upon how we want to define all of that. And then folks of sort of Asian-ish, kind of, we have non-Hispanic whites, we have European or Caucasian whites, then we have sort of Asian, quote unquote, white is how the NHANES data tends to break these things down. And then they tend to be the lowest group out of all of this. Okay. So here we have self-reported prevalence among non-Hispanic Black, or what we think of typically as African American adults. And so when we say non-Hispanic, these are kind of, if anybody has watched the new movie that was from Lin-Manuel Miranda's Broadway play In the Heights. They're in a place in New York, but they have folks that are of sort of like Haitian and the Dominican Republic and those kind of places, which we would consider, they are considered sort of Hispanic Black adults. This is non-Hispanic, so people mostly of kind of African descent, as that may make them a little bit different than sort of Caribbean descent in some ways. But what you see is that much higher rates of obesity among sort of Black adults than we see in non-Hispanic whites, in Hispanics, and in sort of non-Hispanic, non-Caucasian, or sort of Asian descent whites in this way. Okay, this corresponds to higher rates of cardiovascular disease, higher rates of type 2 diabetes, and some other complications that we see that are going to be more prevalent in what we think of as this kind of ethnic minority that is African Americans in this way. So the types of chronic diseases that they have are going to be different than, say, the types of chronic diseases that folks that are of European descent like me are going to be kind of at risk at. And so there are some differences in all of this, and it's really important for us to understand these things because there's really important kind of cultural differences and genetic differences and things, so that we need to make sure that we can understand and target the right kinds of intervention and healthcare access and things into these kind of individual populations, these individual kind of ethnicities, to try to make sure that our interventions are going to be as useful as possible in the midst of all of this. Okay, here's the same data among Hispanic adults, and so you will note that we're getting some shifting in some of these kinds of things, kind of into Texas and Oklahoma, even out into California and Arizona. And some of this is related to kind of the locations in some ways, like where do these individual kind of ethnicities tend to cluster and live. But in general, it's the same kind of a thing. We've got to be very careful in folks of Hispanic descent and of African descent. They tend to have type 2 diabetes and obesity occur at higher rates. I don't have the data on here. I need to put it on there, but if we also look in folks of Native American descent, they also tend to have much higher obesity rates than kind of non-Native Americans. And so these particular ethnic minorities, which are kind of growing in the country, are going to be kind of experiencing different sorts of issues, and we need to understand where those things come from and how much of it is genetic and how much of it is cultural and behavioral, so that we can address kind of the chronic disease implications of all of this. Okay, so some really I think important and fascinating sociology that's related to all of this. And we need to do a better job of understanding that, because depending upon if you want to be a doctor or a nurse or a physical therapist or a strength and conditioning professional, based upon the groups of people that you're going to work with, based upon where you live and those other kinds of things, then there's going to be differences that we need to kind of be culturally sensitive to. And that can help us to get the best outcomes in all of those things. I think we're going to see a lot of research coming in those areas. Okay. We talked about this a little bit last week, but why people are obese is a really difficult question for us to answer. Okay. It's really difficult. There's going to be this very complex interaction between genetics, the environment in which you live, and your sort of individual behaviors in that way. We know there are people that are genetically predisposed to be obese. It runs in families and those things. We know that there's some of that. We know that there are different physiological and psychological kind of issues that may play a role. You can have sort of hormonal imbalances and things, like if you have low amounts of thyroid hormone, let's just say, that's going to be a change in your physiology that is going to predispose you to being obese. If you have very high levels of thyroid hormone, you can be real nervous and twitchy, but you're probably not going to be obese because of all of that. Psychological, emotional trauma seems to play a big role, kind of this behavior and environment things that are going to be in there. People with post-traumatic stress disorder, people that have had some sort of physical or mental abuse or something that have gone on, they tend to also be kind of on either end in a lot of things. You see folks that have eating disorders and are very skinny in them, but then you also see higher rates of obesity. There are cultural and familial factors. Sort of different cultures value different sort of body types and sizes. as being worthwhile or attractive or various things. And so there's going to be some differences in all of that. And then there's going to be some kind of conforming or confirmatory behaviors that may be undertaken in an effort to sort of appear and meet whatever that cultural sort of thought process on attractiveness is going to be. Some really fascinating research on some of those kinds of things. And then the obvious ones that we think we have a little bit of control over, sort of diet composition and physical inactivity, are also going to be really, really big kinds of things. Okay. All right. Mia, you had a question.
So I don't understand how like diabetes and like cardiovascular disease would be like genetic.
Okay.
Like I understand this like, you know, mostly within like ethnic cultures or whatever. But what if, you know, technically you eat different like healthier things like that? Because I know a lot of that comes from eating a lot of salt and things
Right.
like that.
So, you have asked an incredibly complex question to be able to answer in that way. And so what we think of out of all of this, so there's some, think about how to put this in the clearest way possible. So there's some level of genetic predisposition to cardiovascular disease and diabetes that is probably independent of obesity rates, that's probably independent of diet composition and physical inactivity, that's we might think of as it's genetic, but it may not necessarily be related to any sort of behavioral thing. And in that way, it may not even be related to anything that has to do beyond kind of what your parents are passing on. So it may not even be sort of an ethnic related kind of genetic type of type of predisposition. Although we can argue that the pools of genes, there's much less. There's a fascinating book if anybody cares. It's called The Sports Gene, and it's a fascinating look at people that are really good sprinters and really good distance runners. And the most elite sprinters in the world tend to be of West African sort of heritage, and the best distance runners tend to be of East African heritage if we look at these things. And if you look at the sort of the genetic diversity within those pools of things, then there's much less diversity in people of sort of West African descent and East African descent than people that are from sort of Europe or Asia or some other kinds of things that are going to be there. So there's some ethnic stuff that's going to be in here. But there's some level of this that's due to that. Then there's some things that are going to behaviorally interact on top of that based upon sort of ethnic culture, differences in culture, differences in food composition, and those kinds of things that are also they're going to also kind of lay on top of all of that. And so a lot of cardiovascular disease is related to things that you're eating, and it's related to inactivity and obesity. And so that stuff, and that is in many ways, that may interact with the genes, but a lot of that is completely independent of genetic predisposition. Like it doesn't really matter where you're if you guys really wanted me to, for a lot of people, I can make you engage in certain behaviors and I can give you high blood pressure and coronary artery disease and those kinds of things. We'll just go to Chick-fil-A every day for lunch, and we'll go to Olive Garden for dinner and get all you can eat pasta, and we'll just sit on the couch and watch TV the rest of the time. And I can probably give just about everybody cardiovascular disease and type 2 diabetes if we do that. And so that part of it, this is why we don't understand, like there's this interaction of all of these things that are going to mix together. And that's why it's really hard for us to kind of tease out these things. But the thing that we do know is if we look at kind of population-wide, we see higher rates of obesity and we see higher rates of cardiovascular disease and type 2 diabetes in sort of different ethnicities. And we see things that are different among age and all of that as well. So I know that's a really hard question for us to answer, Nia. And I wish that I had a better way to do all of that.
So what are the more prominent diseases in European like race? Like
Hmm. So that's a good question. Um, there's certain kinds of cancer that are going to be more prominent. Um, and then a lot of the ones that are going to be in sort of European ones are people of European descent are kind of these much more rare genetic disorders. There's a thing called Tay-Sachs and some things, and they tend to cluster, interestingly enough, in kind of people of European descent, but that are also of kind of have particular religious practices where therefore they kind of intermarry within their religion a lot. There are certain kinds of like people that are Orthodox Jewish. Um, the genetic diversity, because they tend to all kind of marry within the religion, is going to be less. Anything like that limits genetic diversity. And to be honest, in some ways, if we were to look, there's probably less genetic disposition in what we would think of as traditional European kind of folks of European descent, because there's much more genetic diversity, because people have there's been more intermarrying and things, or having kids among people from all across Europe and Russia and those things for a longer period of time. And in some ways, the good part of all of this, as we become sort of more and more diverse, which I think is a good thing in who's getting married and who's having kids together and all of those things. And genetic diversity is good for preventing diseases and those kinds of things. And so I think as we can increase all of that, we'll be in a little better place. So, but you see some kind of rare genetic disorders and stuff, but they tend to cluster in the religious groups that are going to be very kind of, it's culturally for them that you marry within the faith kind of thing, if that makes sense.
okay.
We've now had the sociology of disease by Dr. Black, and we've really reached the end of a lot of those things that sort of I know. But I think we probably have some classes in sociology department with folks that have kind of public health things that people know a lot more about all of that than I do. But I find a lot of that stuff to be really fascinating. So okay. Um, And so being overweight and obese increases the risk of pretty much every chronic disease, but it's really going to be this big increase, especially in type 2 diabetes. And then the things that predict cardiovascular disease. So hypertension, what we call dyslipidemia, which is elevated blood cholesterol levels. Okay. These two things are going to really play a big role in the development of heart disease. We'll start talking more about that later on today. But we also see mood disorders, anxiety, depression, and things that are going to be related to higher levels in people that are obese. There's a thing called fatty liver disease that we tend to see more so in people that are obese, and then certain kinds of cancer, especially. And I need to go back and look. I feel like it's premenopausal breast cancer tends to be a thing that is related to rates of obesity risk. Premenopausal, other kinds of cancers that are related to obesity tend to be colorectal cancer, as well as like prostate cancer and those things. Okay, so lots of things that are going on. Obesity is a major health problem. You can see this. We talked about our BMI and excess mortality. We've already hit this one. We already hit this one, which I told you was the really important thing, right? That being obese, but getting a lot of exercise and having a relatively higher VO2 max. So red is going to be indicating fit, right? Higher levels of VO2 max within your individual BMI category is going to be very, very protective. So much, much better in many ways to be fit and obese than to be normal weight or lean and sedentary. Okay. So this idea that fitness in many ways can counteract a lot of the negative side effects of obesity. We have a lot of data on all of that. And so you need to get people moving and exercising regardless of whether they're going to lose weight or not. If you want to keep eating Doritos and Chick-fil-A and all of that, then in some ways more power, because I'm right there with you. But we've got to get off our butts and go and run and be very, very active in that particular way. Which in some ways, you know, have a toddler you have to chase around. That'll do it for you. We can have better kind of health outcomes because of all of that. Okay, so I'm going to do just a couple of brief things to talk about body weight regulation, and then we'll kind of move on from here. Please, 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 please do not take this to be the comprehensive thing about why it is that you weigh what you weigh and why your body composition is what it is. I'm going to give you guys kind of just some basic thermodynamics and kind of what we know about all of this, okay? And then within all of this, there's going to be some more complicated issues that we've not fully worked out, okay? In a very general sense, though, your body weight is what it is, and your body composition, the composition of whatever it is that you weigh, is very much going to adhere to what we call the law of thermodynamics, which is going to be that, right, like energy is neither created nor destroyed or whatever, it just moves from one place to the other. And how that applies is that if you take in more food or more energy than what your body needs on a particular day, and you do that consistently, if intake exceeds expenditure, then your body is very good at trying to store any extra intake because it's worried about maybe in some ways that you may not get enough calories tomorrow. So we're very good at storage. So if chronically our intake exceeds our expenditure, we're going to add weight, especially as adipose tissue, okay? This is sometimes referred to as, most often in a very negative connotation, especially by the cult of low carb, high fat people, and I call them a cult because it's kind of like CrossFit in some ways. If I'm a low carb person, I must always talk about that I'm a low carb person, and I must put it in my Twitter handle and put it on my Instagram story, like first things first, right? Like, I'm Chris, I'm from Oklahoma, I'm a low carb, high fat person, right? And I've been doing it for 2 years and it's changed my life or whatever. I just feel like that's a thing. Maybe it's just a social media thing. But this is sometimes referred to as calories in, calories out, or the calorie in, calorie out model of things. And I can assure you, okay, that calories in, calories out is not, is a very unsophisticated way of looking at this. And there's plenty of circumstances where calories in and calories out is not quite as simple as we would like for it to be. But I promise you, if over time you consistently eat more than you need, you're going to gain adipose tissue. I can also tell you that regardless of what it is that you're eating, if your intake is less than your expenditure, you're going to lose weight. And that composition of whatever it is that you're losing, some will be fat, some will be muscle, some will be water. That's going to vary based upon kind of other things that you're doing, okay? But you go on Survivor and they don't give you any food, you're going to lose weight. Or you go on whatever it is that Naked and Afraid, XL, Super Survivor, kind of thing, you're probably going to lose weight. If we go to CC's and, eat the buffet 2 times a day for 6 months and we eat as much as we want, we're probably going to gain some weight. Okay, so in a very general sense, this is a reasonable way to model some of this kind of stuff. Okay, Nia, you had a question.
Never mind.
Never mind?
Mm-hmm.
Okay, so if you want to alter your body composition, if you want to alter your body weight, we can do one of 2 things, right? That in a very simple way, you have to alter your intake or you have to alter your expenditure. So if you want to gain weight, you need to eat more or expend less and put yourself into a positive caloric balance in that particular way, okay? The easiest way to gain weight is just to eat more, all right? It's pretty easy. Although there's plenty of people, especially at y'all's age, or even younger, that can eat whatever they want. They don't gain any weight anymore. They have a hard time actually gaining weight. We don't fully understand all of that. But for most of those people, that's gonna, as someone that was that way at one point in high school, that is clearly no longer the case. That has age has taken that away from me. And that was a hard life thing to have to realize, but that happens. If you want to lose weight, you need to either lower your intake or you need to increase your expenditure. And what I will tell you guys is that it's much easier. It's much easier to alter one way or the other intake than it is to alter expenditure. If you want to put yourself into a negative caloric balance to lose weight, it is hard. It's very hard to do enough physical activity to achieve that. Okay, it's very hard. So if we imagine, if we imagine that you burn approximately 100 calories-ish, okay, for every mile that you run or walk or something like that, you've got to do a lot. You've got to do a lot to do enough to put yourself into a negative caloric balance. Okay, I've got, let me see what I have here in my office. I have these Ritz cheese and cracker snacks that I may have for lunch today. So 13 of these little things, okay, is 160 calories. 13. So if I have basically, let's think about this. I can have about 8 of these, and I have to go run a mile to expend an energy that's equal to eating like 8 of these little crackers, okay, these little cheese and cracker sandwiches. So there we go. I'm eating 2 right now. I got to go run a lap around the track to burn off this if I was interested in trying to keep my caloric balance exactly equal from that standpoint. Okay, so it is hard to lose weight or gain weight by altering expenditure. It's much, much easier to change intake in that particular way. Okay. All right, let me look at a couple of things. These last couple of slides, don't worry about those. Dr. Pinku likes to give an example of that. Basically, if you look at the energy intake, how many calories there are per gram of something, that carbs and protein are one thing, fats are something else, alcohols are something on top of all of that. And then he has people try to calculate if you want to drink 1 bottle of Heineken. I don't really know why he chose Heineken. Or anything else, or why he has chosen beer, but we could look at what's kind of on my crackers. If you know the number of grams of your individual macromolecules, you can calculate roughly how many kcals are going to be in those, or you can just look on the label and it will tell you what it's going to be. Okay. All right. I want to end with a couple of things here. Right. One of the reasons, and I don't know why it's not in here. I need to figure out where that has gone. As Americans, okay, the average American between 25 and 45 gains 20 pounds. 20 pounds between 25 and 45, okay? I am that statistic, okay? I am that statistic, plus maybe a little bit, okay? So if we're normal weight now, or you're normal weight in college, or somewhere in that area, the average person is going to be at least overweight or potentially nearing up towards being obese by all of that. And you say, well, how does that happen? And I say, I don't know, okay? One, our muscle mass declines, our metabolic rate goes down because of all of that, our physical activity declines, but also this, okay? If thermodynamics works perfectly, which of course it doesn't, but let me give you an illustration of this, okay? You guys know what a mini Snickers is? What a mini Snickers? Little mini square Snickers, 50 calories, okay? If you ate an extra mini Snickers a day, if you exceeded every day for a year, you ate 50 calories more than what you need based upon your metabolic rate and your activity levels. an extra Snickers, little Snickers every day, you're going to gain, okay, you're going to gain 5 pounds in a year, okay? 50 extra calories a day. And over the course of a year, you gain 5 pounds, right? It's bonkers. And so you wonder, how do we gain 20 pounds over the course of 20 years? That's how we do it, okay? It's this very gradual sort of creep where we eat a little bit more, we move a little bit less, we lose some muscle mass and those kinds of things. And we're doing all of that, and it's going to, I mean, it literally kills us. Because you get to a certain place and then it becomes hard to lose, to kind of lose some of that weight. And who cares about whether your pants fit or an appearance or anything like that? The big issue is going to be that it predisposes us to this host of chronic diseases. And that's the real thing that can have these kind of dire health consequences in that particular way. Okay. All right. So I'm going to stop sharing. What we're going to do to start with is the next thing that we need to cover in class is something called a health appraisal. Okay, it's a health appraisal, and the general idea behind doing a health appraisal is this: exercise is good for us, right? Like all through class up to this point, you guys feel like that's a pretty major thing that I've at least tried to like hammer into your heads. Exercise good, sedentary bad, right? Like we're okay with that. If somebody asks you, what have you learned in Dr. Black's class so far this summer, that's probably a pretty reasonable thing you would say. Maybe. Okay. So I haven't told you guys the whole story yet though. Right? There's anybody watch the ESPN documentaries? They call them 30 for 30s. They always advertise them. They always start with a, what if I told you that what you think you know, you don't know at all, right? Or what if I told you that all that you think you know about the New England Patriots and Bill Belichick is wrong, right? But so what I'm going to tell you is, what if I've not told you the entire story about exercise? Yes, it's good for you. Yes, it will help you live longer. Yes, it will do all of those things. But the ugly little secret about exercise and why we have to do health appraisals is that exercise will also kill you, okay? And we have to find a way to balance those two sort of competing things together. And so that's what this next kind of lecture is going to be about. How do we go about doing those things, okay? So exercise and physical activity are good. They will help you live longer. But every time you do it, every time you exercise, you are taking your life into your own hands, because when you go to exercise, you are raising the risk that you're going to have a heart attack or some other sort of cardiovascular related, conduction event or something that could kill you. It's much higher when you go exercise than it is just sitting there not doing anything. Okay? So here's what we're going to do. I'm going to put you guys into groups, okay? And your group is going to do two things for me. First and foremost, what your group is going to do is you're going to tell me, okay, just how risky you feel like exercise would need to be that it would make you not want to do it. I do it and it's good for me, but also how risky does it have to be before I'm going to be like, you know what, I'm not willing to kind of go out there and go run today for fear that I'm going to have a heart attack, basically. Okay? Because there is an increase in your chances of that every time you go and do something. And yet, for the most part, all of us go and do it all the time, and we don't even think twice about it. So I want you to think about what that would need to be. The second piece of things, okay, the second piece is where the real crux of this is going to come in. If I want to know, let's just say, okay, if I want to know how risky it is to have Aaron go exercise versus having Madison go exercise today, okay, what questions do I need to ask them to understand that? What information do I need to glean from a person before they're going to go and do a bout of exercise that might help me as the person responsible for their safety. And by responsible for their safety, I mean as the person who is likely to get sued, okay, if something happens to them because I told them to go and exercise. What would I need to ask? What information would help me decide, okay, it's too risky for Aaron. I don't want to make this decision, but it's okay for Madison to go and do it. Okay? So what information do I need? So those are your two things in your group. How risky would it have to be for you to decide, you know what, I'm not doing this? This is a fascinating debate to me, right? Think about what you did or did not choose to do because of COVID, right? That first time when it was going around, did you still go on spring break? Did you go someplace? Did you not wear that mask at some point when maybe you should have, right? In the midst of those things? Some of you may have never worn a mask. Some of you may also have not gotten vaccinated, and you think that, you know what, I've looked at the risk and I've decided that it's okay. I'm willing to take those kinds of risks and those things, right? Like, this is the question. What is your tolerance for risk? Okay. So what does that need to be? And then what else would I need? How would I get this information to know? Some people it's riskier than others. And what information do we need to make that decision? Okay. All right. So there are 20. So there's going to be 19 of you guys. I'm going to resume recording. So let me think about this. My other group. So Taylor, what group who was in your group, Taylor?
Jacob and Araceli.
Okay. So what did you guys come up with? So what questions should we ask people to decide how risky it is for them to go and exercise today?
We said, like, do you have any like previous like health conditions, like anything
Okay.
that could be a potential problem? And what,
Go ahead. I'm sorry. I'm jumping the gun. Please finish.
like, what's your like overall fitness level, you would say?
Okay. Well, how would you know what would you ask me if you wanted to know my overall fitness level, or if I had some other kind of like previous like kind of health condition? Like, what would you ask me specifically?
Like what health conditions like were, and like have you had issues with those when you've exercised before?
Okay. So we just say like, do you have a health thing? Okay. That's perfectly fine. What if I'm forgetful because I'm old and I'm crotchety? And those things, right? So we want to ask, right? Like another thing. How would you know like how fit I am? And why do you think that how fit I am would matter? Well, ask one of your other group members. Araceli, what do you think? How would you know how fit I am? How would I convey to you how fit I am?
Just how long your endurance can last, maybe,
Okay.
or how fast or slow you do something.
Okay. Perfectly good way of getting at those things. Okay. Good.
We also mentioned if you questions you could ask like nowadays is, have you ever had COVID?
Okay. Have you ever had COVID? Okay. Even though that is HIPAA protected information, as far as I am aware, no, I have not had COVID. So there we go. Okay, good. Let's do another. Look at the other groups that I didn't make it to. Jessica.
Yes.
Did I make it to y'all's group? No, I don't.
No, you didn't.
Okay, who is in your group?
I had Jenna, Emma, and Addison.
Gemma, Anna, and Addison. Okay. So what did you guys come up with? Let's start with how risky did you guys think it would need to be to make you not want to exercise? And then we'll go into some of your questions. What did you guys come up with?
We were talking about how if the weather is like too hot or the high humidity to exercise, to where we'd be like in danger of like suffering from heat stroke or something, that would probably be too much of a risk.
Okay.
It'd have to be like moderate to high risk of death or serious injury. One of the examples we brought up was like rock climbing, like the free climbing. That's kind of one of those things we
Yeah, no, I'm very risk averse in those ways. Like no way I'm free climbing any of those things. That just seems dumb, right?
Yes.
Like, you know, we're in the middle of the season where I think people are about to start trying to summit Everest here very soon. And that's like a coin flip, basically. Like, it's a 50-50 proposition. Like like half of the people that try to summit Everest die over kind of a long period of time. That just seems dumb to me. I'm like, I don't care. I don't need to know that about myself. Like, it's not a thing, right? Like, that I need to be aware of. It's worth like trying to climb Everest. But I'm, maybe that makes me risk averse or cowardly or something else. But those kinds of things. So what if for you guys, Jenna, what if it was a 50-50 coin flip? You want to go run today, but there's a 50-50 chance that you could go into cardiac arrest if you went to run. Would you go?
No, I would probably sit that one out.
Okay, what if it was 70-30, like 30% chance that you'd have like a heart attack or cardiac arrest? Would you go then?
I mean, that's more reasonable than 50-50, but I still don't know. It still makes me nervous.
Okay.
But I might go.
What if it was a 1% chance?
Then I'd go.
Then
Like, I
you'd
feel
go?
like anything below like 10% I'm okay with, but anything
Okay.
higher, like 10 up is where like I get nervous, and then like lower than like 30 or above 30 is like when I'm
So we're
probably not
learning things about Jenna and her sort of risk tolerance. Okay. Addison, what about you? If it was 10% chance you have a cardiac arrest and you might die to go run today, would you go?
Yeah, I would go.
You would go. Okay. Interesting. What about like 25? 1 in 4 chance. Would you go?
I'd probably still go.
Okay.
I just feel like it's
50-50
like,
you going?
no, probably not 50-50, but anything like under like 35 or 30, I would probably go. So
Okay.
I feel like modern medicine, I just have too much faith in, I think.
Right. I'm going to go into cardiac arrest, but somebody will save me kind of thing.
Yeah. You can't live life in that much fear. I feel like, I don't know.
Okay. Y'all are braver than I am, in many ways.
I don't have a family though. Like, I don't have a kid that depends on me. So like,
Right?
I'm,
You have other family, you have other people that probably care about you and that you care about in those kinds of things, right? So this is interesting.
yeah, but it's
So,
not like, I don't know. It's just different.
I know. So we have with all of this kind of ventured into an area of something that's called behavioral economics, which is a kind of fancy way of talking about sort of decision making, right? And so economists assume that all humans, when they do things, are rational and will make sort of decisions like, okay, well, I'm going to weigh out the decision that, a 10% chance of this versus a 90% chance of this. And so I'm going to go with the 90% chance. Or, there's a 70% chance that I will lose $10, but a 30% chance that I'm going to win $100, and people will do, and, the numbers tell us we should do one thing versus the other. And what we find is that people are completely irrational. And so to me, I would argue that what Addie just said, while in some ways admirable, is just completely irrational, right? I mean, if there's a one, I don't know that you guys really understand like what a 1 in 4 chance is on some of these kinds of things. I mean, if it's basically a coin flip that I'm going to die today, like, would you get in a car and go drive if you thought it was a coin flip? In those kinds of ways. So what we find is that, people like me, like Addison had talked about, people like me that I have a daughter and, some things that I care about, I'm probably less risk and more risk averse than some other people because of all of this. But this tells us a lot, right? So the real question, Addie, and you don't have to answer all of this, it's like, does that like go out into other parts of your life, right? If you're more willing to go exercise and do that, then are you more willing to drink and drive? Are you more willing to smoke or have unprotected sex or run a red light or pick some sort of at-risk behavior, which is pretty much everything. I guess we should consider like eating chicken fingers and Doritos to be an at-risk behavior. But that would be a way for me to conceptualize it to get me to stop, in those ways, right? And so, do you guys make a different calculation than I do? Maybe you do. Okay. So as it relates to all of that, I'll talk briefly, then we'll get a little bit more onto some of our questions here. We'll do one of the other groups on some questions, and then we'll kind of call it a day for today. So exercise is good for us long term. There's some percentage of benefits that we could calculate, right? Like reduction in mortality risk and cardiovascular disease risk and these things. We can put actual numbers to it. But there are also actual numbers that we can put to your risk of going into cardiac arrest, having a heart attack, or basically dying during a particular bout of exercise. One of the things that we know is that every time you go and exercise, you're going to raise the risk of having, a heart attack or going into cardiac arrest about 10 times, okay? Now, I was asking some of the groups that I went to, I was asking, like, do any of you guys know anyone, right? Do you know anybody? Do you know anybody that knows somebody who's gone into cardiac arrest during a bout of exercise, like while they were exercising or while they were out mowing the yard or climbing upstairs, carrying groceries or something like that? And the answer is we probably, there's enough of you in here that we probably, some of you guys know somebody or know somebody that knows somebody that has. But it's not like every one of you knows 3 people that that's happened to or something, okay? And so even though your risk goes up about 10 times during a bout of exercise, the risk of that happening is still incredibly small, especially in people that are in where most of you guys are going to be age-wise. People that are under 25, in women under the age of 25, it's like 1 in 966,000. Or those are the odds of you having cardiac arrest during a bout of exercise. In men, it's like 1 in like 550,000 or something under 25. You get to be my age and it goes up, it's like 1 in 70 or 1 in something like that, 70,000 in those ways. So it's still very, very small, okay? But it's much higher percentage-wise during exercise than it is at rest, okay? So in that way, we can couch exercise as both a beneficial but also an inherently risky behavior, because it is but in that way, the benefits probably in most people dramatically outweigh the risk that you're going to develop, right? Like, if there's I don't know, whatever 1 in 900,000 chance of something happening is, that's way, way, way less likely than the chances that if you sit on your couch and you don't do anything that you're going to develop cardiovascular disease or diabetes or something else. It's going to be a health problem, okay? But I just want you guys to keep that in mind. And so because of that, we want to make sure, as people that want to maybe encourage others to exercise or go exercise ourselves, we need to understand that that risk is not equal among everyone. There are some people for whom it is much, much riskier than others. Part of that has to do with age, right? It's riskier in me than it is in you guys because I'm older, but then there's a bunch of other things that we might want to get at. So one of our group was talking about, do you have other kinds of health problems, or how fit are you in some ways, which might give us some indication, okay? So we'll do one of the other groups. So Chandler, what did your group come up with on the questions that we should ask people? We want to know if it's riskier for you than it is for, say, I don't know, I'll just pick somebody. Ireland, what should we do? What should we ask?
We said to ask if there's any underlying health conditions.
Okay.
Or any previous family history.
Okay, a family history of what? And were you guys any more specific on what are the health conditions we need to be concerned of? Like, I have eczema, or I have to wear glasses. Is that a health condition that we need to be concerned about for this?
We said cardiovascular disease or just any heart condition, and
okay,
also
good.
Asthma or any breathing issues, I guess.
Okay, very good, very good. And then what about my family? What do you need to know about my family history?
If they've had any of those conditions listed.
They have those. Okay, okay. Why would my family having those be of interest or potentially be predictive of whether or not I might have them? And I'll ask, so Sydney, are you there? Why do you think knowing a family history might be useful?
Because it's possible to inherit those diseases
Mhm.
by generations.
Perfect. Those things are very often going to run in families. So if you're, we know that if your parents have a heart attack or somebody in your family has a heart attack before a certain age, or they have high blood pressure or something, then that's going to predispose you to be at a higher risk for those kinds of things than somebody whose parents haven't done all of that. Okay. So that's kind of the end take home from all of this that I want you guys to get. Okay. Exercise is really good for us. Physical activity is really good for us, but it does actually increase by a significant amount the risk of us having cardiac arrest or something during a bout of exercise. But that risk is still very, very tiny. But there is risk nonetheless. And I can tell you all that if you take a person who had a heart attack 2 weeks ago and you want to exercise them, their risk is way, way, way higher than it is for somebody that hasn't. Okay. They're in the like 1 in 10 kind of range of all of those things. And so what we want to do then to try to quantify or get at that risk is we need to take a health assessment or a health screen on people and try to identify, are there characteristics, are there family histories, are there certain behaviors that people may be sort of current or recently engaging in that might raise their risk level, that's going to maybe throw up a red flag for us to want to have them go and get some further medical testing done just to make sure that it's safe. Okay. Because obviously if we're prescribing exercise for people, we don't want them to have a cardiac arrest. We don't want them to die, right? Hopefully because we're not psychopaths and we care about other people, but also because we don't want to get sued, right? Addie has lots of faith in modern medicine that they're going to save her, but then she might also, even though she had to get saved, she might be pissed at me for telling her that she should go and exercise and not worry about what that risk is, even though we ended up saving her, or that the saving her may cost a lot and she may want me to pay for that because I encourage her to go and do things. All right. So what I want you guys to do for tomorrow, okay? What I want you to do for tomorrow is I'm going to release them on Canvas, but there are 2 screening questionnaires. One is called the PAR-Q, and then one is called the Health Screening Questionnaire, or the HSQ. I want you guys to download and try to complete both of those things before you come to class tomorrow, okay? Fill them out. The information that is contained in those is considered HIPAA-protected health-related information, okay? So what we're going to do, though, tomorrow is we're going to talk about why they ask the questions that they do on those things. And so I find it to be helpful for you guys to have at least gone through them on the front end. And then anybody that's willing tomorrow may be able to, I may ask if you want to share like how you answered a question, then maybe you could do all of that. But that is HIPAA protected information, so nobody has to share anything that's going to be there. But based upon your answers, we can kind of group you into kind of different buckets based upon if there's going to be a level of increased risk for you to undertake certain kinds of exercise. Okay, so we'll do that tomorrow, and then we'll probably get through with that and start talking about cardiovascular disease tomorrow as well. Okay, so what's due tonight?
The critique.
Critique is due tonight. What is also due as soon as you can get it to me?
Our data for the lab.
Your data for the lab. Go do your 6-minute walk test and then send me all of the info that you use to calculate or estimate your VO2 max. So age, sex, distance that you walked, resting heart rate, and if it also asks for your weight, then I need that as well, okay? And I'll put all of that together. It will again be blinded. There'll just be your student ID number attached to it, but we'll do that and we'll split the men and the women out, and then I'm going to have you'll get some means and compare yourself to those. But then we're also going to do a new kind of analysis called a correlation, where we're going to look at and see like Does your resting heart rate, is it related to what your estimated VO2 max is? And things like that. Okay. Aaron, you had a question?
Yeah, for the health questionnaires, do we just send those to your email?
You don't even have to send them to me.
Okay.
I just want you guys to fill them out, and then maybe tomorrow what I'll have you guys do is like flash them on your screen at me or something and show me that you've actually done them, and then I'll take a picture of the screen and we'll give you guys credit for having done that. Okay. It's really just a way to kind of get you to look at something before we talk about them in class, because I think it will be helpful, because we're going to talk about this, and then I'm going to put you guys in groups again, and I'm going to give you guys some case studies, like some scenarios where you're getting information from people, and you'll have to kind of walk your way through with those people through those questionnaires and decide how risky they are. This is just kind of a good way to get some practice doing all of this. Okay. Sunny.
Did you say you were going to send out like an announcement of where we get the health questionnaires? Or I'm sorry,
No, so
I missed
the health questionnaires are, and I'm pulling this up, they're on Canvas.
Okay.
There's a module on, I'm just making sure that I've released it. There's a module on Canvas called screening questionnaires.
Okay, perfect.
In
Sorry.
that module, there's a PDF that's the health screening questionnaire, and it's the PAR-Q. And this may be an old version of the PAR-Q. We'll talk about that tomorrow, but the general gist of what's on there is basically the same. Okay?
Thank you.
You got it. Okay. With that, I bid you guys a good day, and go think about your risky behaviors and whatever it is that you're going to do today, and start making some mental calculations on how likely certain things are to go badly for you in all of those kinds of things. Okay. All right. If you have questions about stuff, let me know. Give me your info, and then otherwise I'll see you guys tomorrow.
Okay, I do have one